So chapter 6 is going to be looking at scatter plots. So 6.1 is going to look at introduction to scatter plots, kind of show you just the ins and outs. 6.2 is going to be looking at the regression equation, how we can use that to make predictions of what's happening with our two variables. Okay, so 6.1 scatter plots. What is a scatter plot? Okay, scatter plot shows relationship between two quantitative variables, and this is an important part. They must be quantitative variables, numerical values that have some kind of scale meaning to them. You wouldn't use jersey numbers on a football team. Those numbers really don't mean too much. One player 5 is no different than player 6. There's no difference between those two. So it has to be quantitative data where there's meaning to it. Okay? Shows relationship, but not cause and effect. You cannot have a cause and effect relationship. That has to do with how the data was collected and where the random assignment was. So this is on be looking at just 4 relationships. We're not going to have any cause and effect. Okay? Now the main point of a scatter plot is looking for that relationship and outliers. A lot of times we're going to see is there any data point that is far away from our pattern. Okay? So if you're looking at a scatter plot, here we're looking at gross domestic products per person, life expectancy, okay, so both numerical values, okay, and we're just looking, these are different countries up here. So you can just see, okay, the relationship between the two, okay, skyrockets, increases very quickly, and then it starts to level out. They're the types of details that I'm going to want you to explain. I want you to go into those details when I ask you to describe what's happening with the scatter plot. We do have some outliers that are sticking out here, okay, so those are the types of things you're going to look at. Decreasing, okay, here we're looking at age versus percent of people, and this is do you favor government spending more on health insurance? Okay, so we have the age on the x-axis, percentage of people are in favor of it on the y-axis. We can see that it's decreasing. Okay, again we have an outlier over there. So just some basic things about scatter plots. If it's decreasing, okay, think about what's happening with the x and y variable. As x is increasing, the y is decreasing. Okay? If we go back, as x is increasing, y is increasing for a positive relationship. So just some things to think about as we're looking through these. Okay? And just one more time. Okay? There may be some cases where you can see the explanatory response variable. Explanatory is going to be the x variable. The response is going to be the y. These are variables being studied, not cause and effect. So just one more time telling you we cannot have a cause and effect relationship. Okay? So we're looking at our scatter plots. Okay? You're going to have to pick out the association. And just like slope, okay, it's going down. As x is increasing, y is decreasing, that's negative association. For positive association, as x is increasing, y is going to be increasing. Okay, so we have positive, negative, and there will be times when you just have points, you really can't pick anything out. For these ones, if I circle them, circle the cluster, you can obviously see it's going down. Circle this cluster here, it's obviously going up. Circle that cluster, there's no positive or negative, it's just a blob, so you wouldn't be able to tell me a positive or negative association. So sometimes you just say none. Okay? Now just because there's no positive or negative association, there might be a different kind of relationship in here. This is just some very basic observations. Now, if I ask you to describe a scatter plot, just like for a histogram, for box whisker plots, if you're comparing them, there's a list of things that you needed to describe that I would be looking for that you were making comments on. Well, the same thing for a scatter plot. So we have trend. Okay? The trend is the positive, negative. Is it increasing? Is it decreasing as x is moving up? The form. The form is linear. And this is the one we're not focused on in 6.2. But is there a curve to it? Is there no form to it? Is it just all over the place? Those are the things that I want you to pick out when I ask you about the form. For the strength of the relationship. Okay, again, no matter how strong a relationship it is, it's not cause and effect, but we can say there's a strong relationship. And this is really looking at how close the points are together. When the points are close together, if they're following a very close-knit line, a pattern, we can say it's a strong relationship. When it's spread out a little bit, the relationship's a little weaker. Okay, we're not as sure as if where the points are going to land. Okay, so the strength is how close the points are, And it is a judgment for right now. For right now, we're just eyeballing, looking at a graph and just making some decisions on basic general observations and outliers. Okay? Any point that's not fitting our pattern, that's not in the cluster, we want to point that out. And make sure you name the point. Okay? Make sure you're saying there's an outlier. Maybe explain why it's an outlier. Okay? Because this is an outlier because for the high X value, it has a very low Y value. And of course, name the variables, but be specific on why you consider that an outlier. Okay, so here we're looking back at the gross domestic product per person and the life expectancy again. If I ask you to describe this, just make sure you hit those 4 points. Now, I really don't care if you're not putting it in bullet points or paragraph form. If you just want to have 1, 2, 3, 4, naming those 4, making a short statement, I'm fine with that. If you want to put it as a paragraph, I'm fine with that as well. Okay, here we have, there's a strong positive association between the GDP per person and life expectancy. It increases rapidly and levels off at about $5,000. There are a few outliers, okay, and then I list them on the bottom down there. Okay, so let's see, did I pick out everything we needed? Okay, we have strong, so right there is talking about the strength. Positive, okay, so it's talking about the trend. Okay, and I labeled the 2 variables, you should always talk about in context. And then I talk about the form. So I had the strength, I had the trend, and then it increases rapidly, and then levels off at 5,000. And there's a very distinct curve here. It goes up, and right there is where it starts to plateau. Make sure you tell me about where that plateau starts so you can get into that kind of detail. And then I talk about the outliers, okay? So make sure you're talking about all 4 of those pieces. You're hitting each one of those and commenting on them quickly. Okay? So here's that age versus percent if you are in favor of government spending on health insurance. There's a strong negative linear association between age and the person in favor of spending. More on the health insurance, there's 1 outlier at about 89 years and 26% in favor. So this time when I'm talking about it, it's negative. Points are fairly close together, so I do say strong, and it is linear. This is a straight line relationship, okay? It's a straight line relationship. There's no bend or curve in it, so that's the linear relationship we're looking for, okay? That outlier there, I picked out that point. It's about 89 years old, and it's 26%, about 26% in favor. So again, pick out that outlier nice and neat where it is. Okay. Correlation's on the relationship we look at in 6.2. For a correlation, it's a special relationship, and that's the one we're not being focused on and how we're not going to need to make predictions. Okay. It's a straight line relationship. Okay. R is the variable for correlation. So whenever you see R equals, it's talking about the correlation. Now, correlation can be measured in a value, and that value is going to be between -1 and 1. Okay? So you're not going to have anything above those or below -1. Shows direction and strength, meaning negative values means we have a negative association, positive value, positive association. And the strength is going to be shown on where the value is. Okay? The closer to 0, the weaker the correlation. So 0 is a weak correlation, meaning we can't see any relationship. And if you look back at those positive, negative, no association, the no association one, that would be a 0 correlation. Okay? The closer you are to -1 and 1, the stronger the relationship. So if you're at -1, even though it's negative, that is the strongest relationship you can have. +1, that's the strongest relationship you can have. Different directions, positive versus negative, but that's the strongest relationship. Okay? So just looking at some of these, okay? Here we have, looking at these 6 graphs here, here's the strongest one. -0.99 is a correlation, okay? Points are indefinite. If I ask you to draw the line of best fit, everyone's line of best fit is going to be pretty much the same. It's a very close cluster of points. It's definitely going down. It's definitely negative without a doubt. -0.99. Now some of the weaker ones, 0.5. Okay, we can tell, even if you circle these like I did before. Okay, yes, it's going up, but look how spread out it is. So it's not quite as strong. If I ask people to draw a line of best fit, there's going to be some difference in everyone's line of best fit. Okay, here we have one at +0.9. Let's look how close I can circle these. Okay, so here you can tell the difference. Definitely both are positive. This one's very little closer together, so it's a 0.9 correlation compared to 0.5. Okay? Here looking at negative 0.3 compared to negative 0.7. Okay? Which one's stronger? The negative 0.7 stronger. Okay? And there, if you look at it again, the negative 0.7 is a little closer. Okay? Still, not the strongest relationship, but it's still a little closer compared to the negative 0.3. Okay? Negative 0.3 is getting pretty close to 0. We would actually consider that a weak relationship. Okay, so how strong is strong? When you're looking at that value of R, what is that value telling us? Okay, the general rule, 0 to 0.3, I would consider that weak. 0.4 to 0.7, moderate. 0.8 to 1, I would consider that strong. Now, of course, your situation's going to also determine some of that, depending on how accurate you want your prediction to be and how accurate your predictions need to be, depending, again, on your situation. Okay, but this is a nice rough estimate of where the weak, moderate, and strong relationships fall in. Okay, you can use that as a little bit of a guide. Okay, if you go to this website, it's a guessing correlation. Okay, this is a good way of kind of getting a little familiar with what a strong correlation is, what a weak one, and just being able to pick them out just by eyeballing a scatter plot. Okay, being able to see the difference between two different scatter plots, which one's strong, which one's weak. So you might want to head there and see what you can do on that website. Okay, so that's 6.1, just a quick overview of correlation, scatter plots, getting a little more detail of the regression equation, and making predictions in 6.2.